Hello, this is Michael Kölling. Welcome back to the Joy of Code. Today we will improve our project a little bit, but we will not add new functionality to it, so we will not actually see anything new on screen. Instead, we will work on our source code here and improve the quality of our source code. When you're a beginner, often people are reluctant to do that because they don't immediately see the payoff of this, but I can tell you that it is very well worth doing. What you can see already here is that our program gets longer and longer. We already have filled a whole page here, and the act method is already this long. There's more and more code in it. And if we go on now writing our source code into the act method, it gets longer and longer and it gets harder and harder to read, and then you will start making errors and it becomes quite difficult to understand what is going on at some stage. So writing code that not only does things the way we want them to, but is also easy to read and easy to understand and correct is important as well, and we will look at that a little bit today. One thing that I have already done is to use indentation and white space, that is, have an empty line every now and then, indent my statements and if statements and so on. That helps a great deal in reading code. Sometimes people write it and have their code looking like this if I delete my spaces here, so that is sort of all over the place. If you do this, it becomes, if your code looks like this, if I delete only blank spaces and I don't delete any other characters, the Java compiler actually doesn't matter. I can compile this, it still compiles, it still works. The Java system doesn't care about the spaces in the code, but for a human reader this becomes really, really hard to read and really hard to figure out what's going on. If your class gets messed up like this, there is in the edit menu an auto layout function. You can do that, and then Greenfoot will fix all this for you again. Okay, but we want to do something that we can't automate. We want to take care of the fact that our act method is getting so long. What we want to do, in fact, is use separate methods for these actions. At the moment, our act method does 4 things. It moves forward. It randomly turns a little bit every now and then. It checks whether we're at the edge of the world and turns then. And it tries to eat some lettuce. So there are 4 distinct separate actions, all coded into the act method. What I want to do is I want to move each of those into a separate method. Let's look at the first one. This is this one is already a single method called a single instruction. We can leave this, but this one we want to take out and replace this with a single instruction that says it. And we can do that by putting that into a separate method. So I can create another method here. So I'm going here to the end of the act method and hit return there. And at that point here, now let me just make my font a little bit smaller so that I get a little bit more text on my screen here. I write a new method. I write public void, and then I make a method for this functionality. This is random turn, I call this. So that's a random turn, and it takes no parameters, so I have empty parentheses, and here is the body of that method. So I'm defining a method. Then I take this code here, that is, I select it all, I cut it out of here, and I go here and I paste it there. And in fact, I've got a blank line here that I don't need. So here I now have a method called random turn that randomly at random intervals turns a little bit. By having this method here, now if I run this, we can actually try that out. If I run this now, you can see, if you look at the movement of the turtle, it doesn't do its random turning anymore. It runs dead straight. By having this code here in its method, now the turtle has the ability to do a random turn. It has a method. If I right click on here, there's now a random turn method that will randomly every now and then turn a little bit. It has the ability to do a random turn, but it doesn't actually do it. Only the act method will get automatically called, automatically invoked by the Greenfoot environment and any other method that you provide here, that you define, we have now defined a method, is able to run, but is not automatically run. So if I want this to happen, I need to now call this method, and I just go to my act method, and here I write a call to this method, and we know how we call a method. We just write the name and the parameters we need, and here it expects no parameters, so we provide no parameters. Now here, when the act method performs, it does the move, and then here it calls the random turn method, which will jump down to here, execute the body of this method, and then return and continue under here. So let's try that out again. I compile again, and now you see my turtle does its random turning again. I equally do the same thing with the other one. Here is the turn at edge. So now what I'm doing here is I write another method which I call turn at edge, and I do the same thing as I did before. I cut out, this time by using my keyboard shortcut. I did a cut and I do a paste here, and I do that for my third thing as well. That is, here it's trying to eat some lettuce, so I create a method. I try to describe exactly what it does, so I call it try to eat lettuce. I don't call it eat lettuce, but try to eat lettuce, because it will not always eat lettuce. It will only eat lettuce if it can actually see some lettuce, so it will try. Well, I'm not sure whether it's such a good name, but it's good enough for now. So I put that in here, and I've got that. Now I can go to my act method, and here say turn at edge and try to eat lettuce. So now if we look at the act method, what is going on here, we can read the act method much more easily at a higher level. We can see when this turtle acts, it will move, it will do a random turn, it will turn at the edge, and it will try to eat lettuce. And then if we are more interested in more detail on any of them, we can just from here go to the definition of the method, and when I say, for example, random turn, and I wonder what does it mean, then I look at the definition of the random turn method and see, okay, if it does a random turn, it actually does this. Now there's one last thing that I should do to make this code better, and that is write comments. At the moment, it relies on me having to read all the source code, and as long as the methods are short, this is reasonably easy. That's why we try to keep all the methods short. The goal is to have all the methods reasonably short, but we can make it even easier by putting a comment with every method. A comment is always written before the method signature. The first line of the method is the method signature, and before that we write a comment. We do that by writing a slash and 2 stars, and if I hit return, it automatically fills in the end of the comment. So here I write a comment that explains in plain English what this method is supposed to do. So I write with a 10% probability turn a bit right or left. Now the comment is ignored by the Java system. The comment is written just for a human reader who later comes and wants to understand our program. We should write a comment for every method that we define. So here I write if we reach the edge of the world, turn a little bit. And the same for check whether we can see lettuce. If we can, eat it. Okay, so there is now an explanation in front of every method what it does, and you will find as your program becomes bigger that this makes a huge difference in how easy your program is to read, because at some stage some of the methods will be longer, they will go over a whole page, and then it is much easier to read here the comment. and decide whether it is worth looking into the source code. For example, typically when we read the code is when something goes wrong. Let's say our turtle runs over the lettuce and doesn't eat it when we had expected to eat it. Then we want to look into the source code and see, okay, where are things going wrong? And here, the names of the methods and the comments tell us where to look. We see this method is to do with just turning. Okay, then I know immediately I don't have to look at this one. This one is also to do with turning. I don't have to look. And this one says, okay, this is to do with eating. So here is where I would start searching. Once our programs are many pages long, it is important to split it up into these separate modules, so that makes it much easier to find the place of code that I'm interested in and to read the code and to figure out what's going on. So make these changes in your own source code, and then in the next episode we will go ahead and make further additions to the functionality. That's it for today. Thanks for listening. Bye bye.